That was a very nice introduction, but the truth is that I'm the one here for two reasons. One, I was the only one from the team who had a white shirt, and second, I was missing from the meeting where they decided who will volunteer. But let's see what we can do with that. So I'll start explaining a bit on how TV evolved from just a one-way communication media to what it is today, and how it blends with the IT technologies that we are all familiar with. So eventually this will work. We started with black and white television. We went through color television. We all know about that. Then the personal video recorder appeared, which was still an analog device, but it was actually the first time when the end user was able to decide when to watch some content. The word time shift was not invented back then, but that's actually what you could do, but in an analog way, not in a digital one. Then, eventually this will work. We had the introduction of digital TV, which did not change too much about the experience. It just increased the picture quality and the efficiency when transmitting the information. Next step was the widescreen and HD introduction. And then IPTV started, which I consider that is one of the major breakthroughs since the color television. Because if we consider that from black and white until IPTV, the communication was just one way, and all the benefits and all what was brought extra was just an improved experience. But once IPTV started, the communication was both ways, and the way people started to consume television changed. So the user behavior and the models of marketing it changed. And now we have multiscreen, which is IPTV inside the customer networks, but also over-the-top television. That means over plain internet. If when the VCR was introduced, you could do time shift, now we can see that you can do place shift. You can be anywhere and watch TV. In the new era, let's say, that's shaping right now, we have the consumer in the center. Before, the consumer was at the end of the chain, so it was fed content according to what the broadcasters were considering fit. Now, the end users are the ones deciding what they want to watch, how, where, and so we are talking about multiple devices. We are talking about content that is constantly changing, because it's not just linear TV and video on demand. You have also user-generated content right now, YouTube, so on. And also the technology that continues to change will shift also some of the behaviors. Better quality, more immersive experience. Now, a few statistics that Ericsson is making about, in this case, where TV is going. One of the things that for some years it was considered that the consumption of TV will decrease after the internet became more and more popular. But in fact, now that people are watching on mobile devices, on web browsers and so on, it actually increases the amount of media consumed. So although linear TV decreased, we have an overall increase on the other screens of 4 hours. Another thing is that the consumer habits are changing. Now all the operators are offering flat rates for video services, and that means that you are more prone to use your device to watch video when you're traveling and so on. Another thing is that the young generations, the millennials, are changing what type of content they watch. Some time ago, you had to be someone to be on TV. Now everybody can be broadcasted over internet. What else is the fact that a new thing that is challenging in this industry is bringing relevant content to end users. So consumers that are using video on demand services spend more time, 45% more time, to find the proper content until they decide to watch something. However, they don't seem disturbed by that, because once they find that content, they are happy with what they are watching and the way they are watching it. And also, once you find it, it's what binging happens, when you start discovering a new series and you keep watching all the seasons. Another fear in the industry was that linear TV was bringing a steady revenue. You pay for your subscription, and that's money that will continue to come. And internet videos were seen as something free. Now people started to consume more and more on-demand services. Another thing to mention here, or to look at, is the way the end users, the consumers, are split. I will focus on 4 of these main categories you see here. So we have, let's say, the traditional ones, the TV Zero guy who was not watching TV at all, and the traditionalist consumer, the couch potato, how everybody calls it. And we see that the numbers for these people are decreasing. So people who are not watching TV before are starting to consume it in a different manner. And people who were sitting in the couch are decreasing and are moving also to other devices. There are 2 new emergent categories. There are what we call screen shifters, the ones that watch TV in the living room but also on the mobile devices. And as you can see in that graph, for example, the consumption for this type of end user is double from the traditional couch surfer. And also we have the mobility-centric people who just watch videos on their mobile devices. And that it's increasing as well. What will happen in 2020 according to the expectations? We expect to have 50% of the content being watched on mobile screens. Right now, the ratio is 40% on mobile and 60% on traditional TV. In 2010, it was 70-30. We expect that 50% of the content will be on-demand content, so linear TV is still there, is there to stay. Since 2010, only the consumption of linear TV decreased only with 1 hour per week. But we have other areas that are growing. And as well, 50% of the consumers will be in the 2 categories I mentioned before. So will be screen shifters that will use basically TV across all devices, and the ones that will be mobile-centric. On top of that, 5G network rollouts will probably start to happen. That will mean a better experience for the end users, better battery life on the phone, and especially they will be able to prioritize the video traffic in the mobile networks. So you'll have a guaranteed quality of service on that. Now going back to the broadcasters, and not only operators and entities that want to enter into this business, they have a few challenges. One is to provide the TV experience everywhere, at any time. So not scheduled TV, it's fading away. Then you need to provide a flexible subscription level. We have customers that let their end users rent channel by channel. You have an online shop and you decide what channel you want to watch, and you'll keep only the relevant ones and pay accordingly. You need to be able to capture the revenue from the video advertising. And also, one needs to focus on launching efficient over-the-top TV solutions. And usually that's a situation that's not very well planned. I mean, operators tend to underestimate the complexity of an OTT solution. Ericsson Managed Player is one of the answers that Ericsson has for those challenges. It's actually an online video platform, an end-to-end online video platform that it's able to do anything from channel acquisition from satellite up to the distribution on the mobile devices. Also, same happens for video on demand. If you consider that you can have a server at home and stream some videos on your living room TV, that doesn't seem too complicated. But when you are talking about carrier-grade solutions, things get a bit more complex. And I will try to separate a bit the areas that are more traditional to the TV side and the ones that are actually pure IT. And that's the area that's actually changing the game. So besides the channel acquisition and compression, video compression, and players that are able to reproduce that, and let's say that the DRM would be something also specific to the TV industry. You need to have integration with the customer backend. This is a platform that is being sold as a service. So it's a white label TV solution that onboards various customers and delivers their content across all the needed devices. And by devices, you can say Android, iOS, web, Apple TV, Chromecast, and so on. In order to do that, you need to have a media management system. You need to be integrated with the ingestion flows. And you need to have also a SDK for the mobile devices to develop applications that are able to consume the content you're producing. Our system has three main components. It has the local component in a few data centers across Europe, where we do the channel acquisition, transcoding, and storage of the actual content. And then the majority of the system is based in cloud, where most of the logic resides. I will elaborate on that later on. What else? Another component is the CRM, which is the integration layer with the customer billing system and so on. And we got that as well as a service with a third party. Now, how does TV content actually ends up on your mobile device? You need, in over-the-top TV, you basically download chunks of of clips, and you play it continuously. And in order to offer a seamless experience, you need to have adaptive bitrate streaming. That means that, let's take, for example, a live channel. It's the most convenient one, I think. You will have a channel at full HD resolution. You will need to transcode it and to make out of it multiple bit rates to be able to play it across all type of networks that you have. Then you need to segment that content in order to deliver it over HTTP, because that's how video content is distributed in OTT fashion. You have a content delivery network, which is, let's say, a geographically distributed network of caching servers that will serve your content over HTTP. And to reach there, you need to transcode it. As I said, you need to segment it in small pieces. And there, for the segmentation, you have different technologies. For example, you have HLS, which is from Apple. You have Dash, which is from Google. And also, your content needs to be protected. In order to be able to broadcast content, you need to have a DRM system that is approved by the studios producing the content. We can provide our own DRM, which is worldwide accepted, or we can go with the ones that are standard in market right now, like Widewine from Google, Fairplay for Apple. Also, the delivery can be done via upload towards the CDN, HTTP, FTP, S3. What happens is that in the end, you will reside with a bunch of small video files and a text file, which is actually the manifest, the table of contents that lists all your files, and the player will parse that file and will decide what to play and in which order. Now, a bit more about the distribution of content. A high level and easy way to do that is to have a central storage, a small cache for it, which can be Varnish, for example, which is widely available. And then you can integrate with the global CDN provider, or Ericsson has also its own CDN. And in simple steps, that's the way you can distribute mobile content. But the fact is that depending on what players you have, on what mobile devices you want to broadcast that, you will need different types of DRM, and you will need different types of packaging. For example, if you want to use Dash, which is native for Google, you will need a certain type of packaging. If you want to deliver to Apple TV and use Fairplay, which is native for Apple, you will need another type of packaging. And in a traditional delivery means that you need to transcode and process each content twice, 3 times, and store it depending on the platforms. What happens now across the industry, and we do that as well, is to do just-in-time packaging. That means that you do the segmentation, and the content is being stored on a centralized storage. And depending on what type of device requests the content, the DRM and packaging will happen on the fly. That's easy to do because there is no video processing involved. It's just header manipulation, let's say. Now, how DRM works. A DRM must have few main characteristics. First of all, it must be approved by all the studios in order to be able to receive the content from them. Second, it must provide unique decryption key per content and also per user. So the keys must not be reusable. Also, the key is always bound to the device. I've listed the main DRM types that we use, and most of them are standards in the industry. And in short, what happens? When the application loads the content, the movie catalog, let's say, you start to access the content, you send a play request, and then that request goes forward to the backend. It will decide if you're entitled to watch that content or not, and it will send you back the key to decrypt it, the key which will have an expiration time. Once you get the key, you can download content and start streaming from the CDN. In order to be able to offer a meaningful experience, you need to have an SDK, and that's what offered to the end users, so actually to the customers. We have the backend, and we have also the SDK that can be used to develop apps compatible with our backend. And usually, here you have an example for an Android SDK. Inside, under the application layer, we offer our own player, and also our analytics module, our DRM module, and a couple of other things, but I'll not put too much emphasis on that. Now, another use case that I would like to show is how ad is being inserted in OTT systems. The mechanism is the same whether it's VOD or if it's live. The only condition for live, to be offered to offer ad insertion for live, is that you need to record that content. So when the content is processed, it will have some triggers added that, okay, this is the place where you will have ads played. When the player starts to play and parses the manifest, the index I was talking about, at some point it will reach a spot where it says, okay, you need to insert an ad. Then it will contact the ad insertion server that will decide what type of ad you will play. And the decision is taken based on the amount of length the slot has. Maybe you have a 25-second slot, and it will need to provide 1 or 2 ads that will fill that one, and also based on your previous behavior. On the channels you watch, that comes the power of recommendation engine and the analytics that is gathered from the end users. Once that the ad is chosen, it will be fed to the mobile player. And then, after that is played, the player will resume to its normal content. What happens after that is that we need to send callbacks that ads were played in order for the broadcaster to charge the ad provider accordingly. Now, that was more focused on the TV part, on the TV-specific area. Moving back to the IT part, as I said, we offered a tailored solution that is addressing different types of customers. So we have customers who are mainly broadcasters, and their focus is to broadcast events like Champions League or clips, and they need to publish those fast on the web. We have customers that need to sell only live channels, and they need a flexible way of selling them. Or we have customers that use the unused time in the network to offer video services. Like you can register to download a movie right now, and it will happen over the night when the network will not be that loaded, and you can watch it after. That means that we need to have modular architecture where we can enable, disable services, scale up according to what our customers want. One of the examples, we can discuss a lot about that at our stand, is, for example, the exposure layer. So let's say that you have the content transcoded and ready for you somewhere, but you need to present it in a meaningful way towards the end users. And what we call exposure layer is actually the integration layer between mobile devices and our backend. It's a RESTful API, and it's based on multiple components. For example, most of them that are used widely on the IT market. For example, we use Elasticsearch for offering the metadata towards the applications. We use Cassandra database for the entitlement server, which actually feeds you the right to play or not the content. We use Hadoop, for example, for big data and further analytics. I'll go forward to that. Regarding the deployment process that we do, the fact that we have a multi-tenant platform implies different type approach in the deployment. We have 4 environments that we work on. The development and pre-staging environment are used and maintained by the development teams. And there they have implemented continuous deployment. They write the code, they test it automatically, and they deploy it in pre-stage. But what happens then is that after deploying in pre-staging, there is an approval step to move it to staging. Staging in production platforms are handled by the operational team, and also on staging, the customers are testing as well. So once we start deploying in staging, then we need approval from all our customers that tests checked out okay, and we can go to production. In terms of the way we release, we use Jenkins for orchestration, and Git for the repository, and all of our images are Dockerized. Not sure if we need to go further into that. But it's also not necessarily a particularity, but for example, when we deploy a new release, we replace the virtual machines with new ones. We destroy the old ones, and we virtually replace the virtual machine altogether. Now, the way of data gathering. Analytics are quite important in this type of business for multiple reasoning. One would be to be able to offer relevant content to the end users, because content will grow more and more. So we need to track the end user behavior and be able to offer meaningful data with them. So in terms of gathering, we gather data from all our players. It was a module in the SDK that you saw earlier that sends data towards our backend. And there are 2 types of data. We collect all the raw data and we store it in Hadoop, but we also collect, let's say, real-time data that's being sent to an event processor, which behind is based on Kafka. All of our backend is developed in Java, and it's also residing on industry standard components. So one type of data we collect is the one from the players. Other type of data we collect is from the third parties that we are integrated with, like the CRM systems in terms of how many users were added and so on. And also we have our own probes. We offer reporting on the system availability, performance, how fast we are able to deliver a certain movie, transcode it, and so on. Now, in terms of data consumption and the way how it's presented, we have 2 types of data, let's say. So we have reports that are available on a daily basis for our customers. Basically, you can see today what happened up until yesterday. And these are the ones in the upper part of the slide. Or you need also real-time data. For example, you need to know how many devices are being used on an account at a certain time. Why do you need that? You need that in order to limit the number of accesses on a subscription. So let's say that you pay a subscription and you want to have only 2 simultaneous devices playing it at the same time. So you need to send some events with the number of active streams and take that into account. And also you need to be able to analyze the session and the end user experience. How many stream failures it had, how many success it was, how often did it change bitrate when it was actually playing content. And that's also a way of understanding the quality of your network. If the player buffered or not along the experience and so on. Now, moving forward to the monitoring, we of course use Nagios first of all for the endpoint monitoring. We developed some in-house tools for flow monitoring because we need to make sure that our backend systems are accepting and processing the requests coming from the customers properly. And we also use Visceral and Hystrix to see the traffic and the behavior of different components. And on top of that, we use Grafana for trend analysis, and it's also helpful on troubleshooting. That's a summary of how an over-the-top TV solution looks like nowadays. Any questions? Then I'm excused.
Anyhow, I guess if you have questions, you can find Sorin at Ericsson right here, right? You have
At Ericsson booth, we can. There are smarter guys there.
What do you use to automate tests? And you show in that pipeline that you have tests to, I don't know.
The development team is also writing test cases also in Java, so they don't use an automated test framework, let's say. On the automated test, we do, for example, we do 2 types of tests. We send different type of assets on different flows to see that ingestion is working fine according to the parameters and so on. And also we test on the API level, we feed a certain input and see what output we need to expect. Our test coverage, automated test coverage of the system, it's around 60%. The difference, up to 100%, is done by manual testing and is done by the end user, the end customers. So all of our customers have their own testing team that are validating the release in staging.
Thank you.